In this video, we will take a look at both questions 5 and 6 of RACE-4 of the Secureum Bootcamp. In question 5, it says that the in Secureum contracts underscore transfer function, so the internal one, is A, missing a zero address validation, is B, susceptible to an integer overflow, is C, susceptible to an integer underflow. So let's take a look at the underscore transfer function, which is right here. We can see that the only addresses that this contract is dealing with are the input parameters sender and recipient. We can also see that right at the start, both of these variables are checked to ensure that neither of them contain the zero address. So indeed, there is no zero address check missing in this one. Then there is the question whether there is an overflow or an underflow. As we've already mentioned, we have solidity 0.8 here, so that means unless there is an unchecked block, no overflow or underflow is possible. In this case, there could be an underflow possible since this subtraction here is within the unchecked block. But as we can see right above, this require statement here ensures that amount cannot be larger than sender balance, and therefore sender balance cannot underflow. And with that, we can say that the underscore transfer function is not missing zero address validation. It is not susceptible to integer overflows. It is also not susceptible to integer underflows. Even though it uses an unchecked block for a subtraction, the underflow is explicitly prevented by a require statement. So moving on to question 6, which is about the underscore mint function. It says here once again that A, it is missing a zero address validation. It B has an incorrect event emission. It C has an incorrect update of account balance, or none of the above. So let's take a look at mint. We see mint right here. So it mentioned the event emission, and we can see that it emits a transfer event with address 0, so that would probably be the from address because it is transferred from nowhere to the account to which it is being minted to with that amount. And if we compare that, as you might remember, we are implementing an interface here, which is IERC20, which comes from OpenSepplin's contracts. And if we open this, we can see that there are indeed two events defined here. One is transfer, one is approval. The first address is indeed the from address, which was in this case the address 0. The second one is the to address, which was the account, and the third parameter passed to this event is the amount, the value, which is being transferred. So all in all, we can say that the mint functions event emission is actually just fine as it is. Then is there a zero address check missing? So we can see that only this account address is being dealt with here. And indeed, there's no check to prevent minting to the zero address. So yes, one could argue that there is indeed a zero address check missing, especially since there is a zero address check in all of the other functions apparently. So maybe just for consistency, this one should also have one. And then there's the question if this mint function incorrectly updates the balances. And we can see that the balances are updated, the account balance is updated right here. And while it seems correct at first, the problem would be if the account already has a balance and new tokens are minted to it, because then these new tokens would simply overwrite the current tokens of that account. So instead of just being an assignment here, this should actually be an assignment addition. So this should be just like above. This should be plus equal instead of just equal. So is it missing a zero address check validation? Yes. Does it have an incorrect event emission? No. Does it have an incorrect update of account balance? Yes. So A and C are correct for question 6, and that was questions 5 and 6.